This is Daryl with Cisco Hands-On Training. It's the 13th of March 2010, and today we're going to start dynamic routing in IPv6. For that, we're going to use the RIPng protocol, which is the routing information protocol, the next generation one, which supports IPv6. Now, I would not recommend that you use RIPng in production because RIPng has similar problems to RIP in IPv4. It sends updates of all its routes every 30 seconds, and it's timer based, so it's slow to converge. But the problem is the routers that I'm teaching classes on are too old, so they don't support OSPF version 3 or ISIS or any of the other, they don't support those more advanced protocols for IPv6. So RIPng is the only dynamic routing protocol for IPv6 that I have available other than BGP, which I will show BGP for IPv6 in a future episode. So we'll get into RIPng, and the configuration is pretty similar to OSPF v3, so that way at least you can see what a configuration looks like for an IPv6 dynamic protocol, because Cisco has changed some things. The website remains www.ciscohandsontraining.com. And for those of you that have thanked me for the webcast, please, I would appreciate if you link to my website. That's the best way to say thank you. And in iTunes, you can search on Cisco Podcast, and you'll find me usually hit number 2. Here is our map for today. It's the same map as last time. All IPv6 addresses start with 2001:0db8:0:, and then the subnet, like 2:1/64, and I've got a /126, and my loopbacks are /128s. Let's go ahead and do I'll put this map on the website in the comments field I'll put the map on the website in the comments field for this presentation. And let's get into it. We need to configure our routers. So we'll start with router top, conft IPv6 unicast routing, int LO0 IPv6 address 2060:001:0:1:1/128. No shut. Int serial 0 IPv6 address 0:010:0:2:1/64. No shut. Int serial 1 IPv6 address 2001:0:db8. And again, shortening rules, I can get rid of the leading 0 in this thing, so I can type it db8:0:1:5/126. Clock rate 64,000. No shut. And normally I would write mem now, but this is a lab, so I avoid that. Conft, so on the middle router, int LO0 IPv6 address 2001:0db8:1:1:2/128. No shut. Int serial 1 IPv6 address 2001:0db8:0:2:2/64. Clock rate 64,000, because this is the DCE side, so I have to supply clock on the serial interface. No shut. Int serial 0 IPv6 address 2001:0db8:0:3:1/64. No shut. Again, I should write mem. Bottom router, conf t int lo0 IPv6 address 2001 colon 0 colon, I'm sorry, 0db8 colon 0 colon 1 colon colon 3 slash 128. No shut int serial 0 IPv6 address 2001 colon 0 db8. Again, the 2001 colon 0 db8 colon colon slash 32 is the documentation prefix. So when you're writing documentation or giving examples, you can use that address block, but you should not use that address block in production. It's not assigned to you. It's just for documentation. 0db8 colon 0 colon 1 colon colon 6 slash 126. No shut int serial 1 IPv6 address 2001 colon 0 db8 colon 0 colon 3 colon colon 2 slash 64 clock rate 64000. No shut. So in theory, all of my interfaces now have IPv6 addresses configured on them, and I should be able to ping the adjacent routers. So from this router, I should be able to ping this address, but I should not be able to ping the loopback address because I don't have a dynamic routing protocol. So my bottom router knows how to get here because it's on a connected interface, but it does not know how to get here because that's a hop away. Again, when you're troubleshooting, it's best to troubleshoot layer 1 and layer 2 first. Make sure that all of your direct links work, and then you can try to get one hop away. So let's test all of our direct links so that way we know that our layer 1 and layer 2 is working before we try to get our dynamic routing working. So ping 2001 colon 0 db8 colon 0 colon 1 colon colon 5, and that's successful from the bottom router. Ping 2001 colon 0 db8 colon 0 colon 3 colon colon 1, and that's successful from the bottom router. And then from the top, so that tested 2 of my 3 links, and then from the top router I needed to ping to 2001 colon 0 db8 colon 0 colon 2 colon colon 2, ping 2001 colon 0 db8 colon 0 colon 2 colon colon 2. And that's not working. So run int serial 0. Show int serial 0. My IP address, my IPv6 address looked fine. My interface is up. My line protocol is up. Show CDP neighbor. Show CDP neighbor serial 0 detail. Looks like I've got a I messed up the IPv6 address on the other side. It should be 2001 colon 0 db8 colon 0 colon 2 colon colon 2. Okay. So here I am in the middle router. Show run int serial 1. Conf t int serial 1. Now let's do something wrong. I'm going to do what I think is correcting the address, and we'll see what happens. IPv6 address 2001 colon 0 db8, well, shortening rules db8 colon 0 colon 2 colon colon 2 slash 64. Show run int serial 1. Now look what happened. The new IPv6 address was added, but the old IPv6 address was not taken away. This is different behavior from IPv4. In IPv4, on a Cisco router, if you configure a new IP address, it replaces the old IP address unless you use the secondary command. So in IPv4, you have a primary IPv6 address, a primary IP address, and then you have 0 or 1 or more secondary IP addresses. In IPv6 it's different. All IPv6 addresses are equal. So you configure one IPv6 address and it's there. You think you're correcting it by typing in another IPv6 address, but you don't correct the first one, you just add a second IPv6 address. So int serial 1, in order to get rid of the other IPv6 address, I need to actually get rid of it. Oops. And now, and there we are. So now my routers can ping each other on the directly connected interfaces. Let's get the routing going. Show IPv6 proto. And the IPv6 routing protocols active right now are connected and static. IPv6 router RIP, and then I need a name of the protocol. I could name it, I could name it Bob if I wanted, or I could name it IPv6 routing not enabled. So IPv6 unicast routing. I configured that on one of my routers during the initial configuration, but forgot on the other two. IPv6 router RIP 1. And let's see what options we have. So we have default, which sets a command to its defaults. We have distance, where we can set the administrative distance, which is the believability of RIPng versus the other IPv6 routing protocols. We can apply distribute lists. In this case, we can apply distribute lists to filter routes. We can set maximum paths, so that way, if we have there's a default maximum paths, but if we have 8 equal cost paths to a destination, the default maximum path might be something smaller, like 4. I don't know which one it is. We can increase that. We can negate a command with no. Poison reverse should be enabled by default, which, remember, poison reverse in RIP, I receive a route from a actually, I don't remember. I'll have to look that up. So I get poison reverse and split horizon mixed up. So the port, and I can set the port and multicast address that RIP next generation uses. If I want to change it for some reason, I can redistribute between protocols. I can set up. I can reconfigure split horizon, although I usually want to set the defaults. I can summarize, and that's important in most routing protocols, because if you want to, if you have an environment with thousands of routes, you would not want you want your routers to be capable of handling them. So by summarizing routes, you can keep your routing domain more stable by minimizing updates and minimizing the amount of CPU that your routers use. And you can adjust the timers to try to make RIP faster, but don't bother go with the real routing protocol like OSPF v3. Okay. What I'm not finding is passive interface default here, which I like to configure in production. I always like to set my routing protocols to be passive interface by default, and then I know passive interface on the interfaces that I want to actually run routing on. Okay, so I've got my routing protocol. You notice there's no network command here. How do we enable routing on an interface? Well, in IPv6 you do it on the interface, on the router interface. So int serial 1 IPv6 RIP, and then the process ID, which I went with the number 1, enable, int serial 0 IPv6 RIP 1 enable, show IPv6 RIP, and you can see I've got RIP process 1. It's running on port 521. Multicast group, RIP actually sends its updates to a multicast address that was implemented in RIP version 2 on IPv4, and In RIP version 2, you send it to 224.0.0.9. Well, in IPv6, RIPng uses multicast and sends the update to the multicast IPv6 address FF02::9. Remember, all IPv6 addresses starting with FF are multicast. 02 is link local scope, so it'll go on the local link but won't go any further. And then : and then 9 is just the well-known address for RIPng. The administrative distance is for RIPng is 120, which is the same as RIP for IP version 4. The maximum paths is 16. Remember I talked about that maximum paths command, so wow, 16 is a lot. So if I have 16 equal paths to a destination, I can put them all in my routing table. Of course, whether a router has the hardware to support that many next hops is another matter. Many routers have a hardware limitation of 4 or 8. But the 2500s that I'm using here do all the forwarding and software, which means they do it slow, but you don't have any hardware limitations. Split horizon is on, poison reverse is off. Default routes are not generated, so I'm not generating a default route, and I've sent 7 periodic updates and 2 triggered updates. Well, why did I send 2 triggered updates? Well, I configured RIP on 2 interfaces. So each time I configured RIP on an interface, rather than just waiting for the next periodic update after 30 seconds, the routing protocol sent a triggered update immediately, and that improves convergence time. I have 2 interfaces with RIP enabled and no redistribution. Let's look at my routing table. Show IPv6 route. And you can see in my routing table, I have my loopback or local connected /128 for the loopback. I have a connected /64 for serial 1. I have a connected local /128 for my IPv6 address on serial 1. I have a connected /64 for serial 0. I have my local /128 for my IPv6 address on serial 0. And then I have 2 local items here. One is for multicast, which I believe, let's see, we have, yeah, this is the link local FE80 and the multicast FF00. Is that link local? I have to look up show IPv6 int. Yes, so you can see here on interface loopback 0, I have a link local address FE80, and all IPv6 addresses which start with FE80 are link local, and then the rest is based on my MAC address. And then I also have the global unicast address that I manually configured. And that's on loopback 0, and the local subnet is a /64. Interesting. Oh, I'm sorry, this is serial 0 here. Loopback 0 is up here, I scrolled too far. Okay, so serial 0 has a link local address with FE80 and a global unicast address that I manually configured. Note that I did not configure the link local address. It just configured it automatically once I enabled IPv6 on that interface. And then the router has actually joined, this is interesting, 5 multicast group addresses. It joined FF02::1, which is the all hosts multicast address. It joined FF02::2, which is the all routers multicast address. It joined FF02::9, which is the RIPng multicast address. And then it joined 2 others. And these 2 others are as FF02::1: FF00:1, which whenever you have one of these where after the first 64 bits it's :1:FF and then another 24 bits, that is the solicited node multicast address for one of the IPv6 addresses on the interface. And remember, that's how neighbor discovery works in IPv6. Because I have an IPv6 address which ends with the last 24 bits being all zeros and then 1, I subscribe to the solicited node multicast address starting with this prefix, ff02::1:ff, and then the last 24 bits are the last 24 bits of my IPv6 address. And then I have another solicited node multicast address, and this one is the one, this is the one where the last 24 bits are 8116C, I'm sorry, 81:16C, and that's because I have an IPv6 link local address where the last 24 bits are 81:16C. So because I have this IPv6 address, I subscribe to this IPv6 multicast address, and that way when somebody else wants to talk to this IPv6 address, they'll send a solicited, they'll send a neighbor discovery request to this multicast address saying, hey, who has this IPv6 address? And because I'm subscribed to this multicast address, I will receive that neighbor discovery request, and because I receive it, I'm capable of responding. And that's how we replace ARP with IPv6 neighbor discovery. Okay, so show IPv6 route. And you notice there are no RIP routes here. Why are there no RIP routes here? Well, the reason there are no RIP routes there is because I only configured RIPng on one router. RIPng is a routing protocol. It allows multiple routers to talk to each other via the protocol. It doesn't help only having it on one router. I need to configure the routing protocol on my other two routers. So let's go to the top router. conft IPv6 unicast routing, IPv6 router RIP1, and then I go into interface configuration mode, int serial 0, IPv6 RIP1 enable, and then int serial 1, IPv6 RIP1 enable. And now let's see, show IPv6 routes only a few seconds later. But you notice I've already received a RIP route. Now that's pretty impressive because RIP sends its updates every 30 seconds, and I just configured this a few seconds ago. But when I configured RIP, I sent a RIP update to this guy, and you know, these routing protocol implementers are trying to improve the convergence times of routing protocols all the time. So I would not be surprised if, as soon as a new RIP neighbor comes up over here, you know, this box sees a new RIP neighbor sending traffic to it, so it decided to respond with its own RIP advertisement immediately. Now the other thing that's interesting is I'm only receiving one RIP route from the middle router. I'm receiving the RIP route for this serial interface here, but I'm not receiving the RIP route for the loopback. And the reason is because on this middle router, I only configured RIP next generation on my two serial interfaces. Now maybe that made sense because I'm only talking to two other routers out those interfaces, but in order to advertise my routes in RIP, I need to configure RIP on all of those interfaces. So likewise on this top router, I only configured on the serial interfaces, which means I'm not advertising my loopback interface. Let's see if I can do a debug. Debug IPv6 RIP. So response. Okay, so I turned off no debug all. Now let's look at what we got. First thing I got, RIPng response received. So that means something came in from FE80 on serial 0. Now the first observation is that I received it on serial 0 where we have a global address, but RIPng is using the link local address to pass the routing information. And that's true for OSPF v3 as well. The routing protocols, even if you configure a global address, they will use the link local address. And that way you can keep your neighbor, your routing neighbor up, even if you change your global addresses. The link local address is stable. It's always going to be there. So I receive, it says a response. I don't know that it's actually a response. I think it just means that it's inbound. And that's just how the program thinks of it. Anything inbound received is considered a response. And I think that's just the protocol as described, RIP request, RIP response. So even if you just gratuitously advertise your RIP routes, which you do in an update every 30 seconds, you just call that a response. Okay, so I have the source of the RIP advertisement, which is the link local address of the neighbor router. It came in via serial 0. The destination was FF02::9, which is the well-known link local multicast, link local scope, the well-known address for RIPng. The source port is UDP 521. The destination port is UDP 521. The length is 52 bytes. The command is, so it's RIPng version 1. The command is 2, and I'd have to look up the RIPng specification to see what that command is. And I have 2 routes that I'm receiving. The route for subnet 2, I'm calling it subnet 2, it's really 2001:0db8:0:0:2:2/64, and it has a metric of 1, which is hop count, and then the other subnet, subnet 3. Usually when I think about routing, usually in an environment you're going to have a /48, so the first first 48 bits are going to be specified, at least in an enterprise. So it'll always be 2001:0db8:0 in this enterprise, and then this 16 bits is the subnet within your enterprise, and then it's a /64. So I receive 2 routes, and each is hop of 1. Now a tag, you can send tags which have information that you can use for protocol for filtering and stuff. We have not configured any tags on our routes. Okay. So that is a route advertisement we received from the middle router. And again, notice the middle router is sending us the 2 subnets that it has RIPng enabled on, but it's not sending us the route for the loopback because it did not configure that. Now, outbound, out serial 1, what do we send? Well, we send, the source is our link local address, which starts with FE80::, and then the last 64 bits are based on my MAC address with an FFFE inserted in the middle, and possibly 1 bit up here changed to a 1 bit here set to indicate that it's a, well, actually I don't know what that indicates. I think it means that it's just, I don't know what it means. But in any event, this is a link local address that we dynamically generate from our MAC address by inserting the FFFE, setting 1 bit here, and then the FE80. The destination is the link local multicast address for RIPng. It goes out serial 0. Source port 521, destination port 521. This is UDP, and the command is 2, which I think is an well, I'd have to look at the RFC to see what that is, but I think it's just a route advertisement. Version 1, RIPng version 1, and then I've got my prefixes, 2001:0db8. This is my loopback, and this is my this first one is my loopback. I'm sorry, this first one is my subnet that's actually on serial 1. And then my second one is the 0db8 subnet 2 is actually my subnet from this serial interface. And then I sent another update shortly after out serial 1, and that update actually had 3 route advertisements. It included the route that I received from the middle router, subnet 3. So the middle router is attached to subnet 3. It sent me the route advertisement with metric 1. I sent the route advertisement out my serial 1 interface. I should send it with metric 2 because that's hop count. And yes, there's metric 2. Okay, and now if I do a show IPv6 route, you can see I have one RIP route in my domain. All of my routes in the top router are directly connected, except that the middle router is sending us this subnet. So I have a RIP route for subnet 3, or I should have a RIP route for subnet 3, and there it is, RIP route for subnet 3. And it has my next hop, which is a link local address, and it's a serial interface. Okay, let's finish the routing domain. So the middle router, int lo0 conft, int lo0 IPv6 Rip 1 enable, and IPv6 Rip 1, I could originate default route, I could offset the metric, I could summarize with a summary address, I can enable or disable. There's no passive interface here. I would like to passive interface on this because it's a loopback. I need to enable it in the routing protocol so that way I advertise the route out to my other routers, but there's no reason for me to actually send advertisements out this interface because there's no reason for me to actually send advertisements out this interface because there's nothing to talk to. But the routers that I'm using are so old and the code version that I'm using is so old, I don't have that capability. But on any reasonable router that's not from the Stone Age, you should be able to configure passive interface. And you should configure passive interface on every interface where you don't talk to another router or don't want to talk to another router. So for example, one example is loopback interfaces. You're not talking to another router, so you should passive it and just save yourself some CPU. Another example is if you have an access subnet where there are access switches. You want to enable that subnet in your routing protocol, so you advertise the subnet to the rest of your routing domain, but you don't want to talk RIP out those interfaces because then a Unix host on that subnet could receive the RIP advertisements and could actually send you bogus RIP advertisements and mess up your routing. You know, why let hackers mess with your routing? You want to protect your routers from the environment because there are hosts out there that try to do bad things. So that's why I like to do passive interface default, and then I would only no passive my two router-to-router uplinks from a particular router. And then on the bottom router, conft IPv6 unicast routing as opposed to multicast routing. And then we're using multicast, but we're not routing it. We're just using multicast on the local links. Int serial 0 IPv6 Rip 1. Oh, I'm sorry. I haven't even need to configure my routing process. IPv6 router RIP. Now I use process ID 1 on the other routers. You want to keep it consistent in production, but just to show you that the process ID is not important in RIP, IPv6 router RIP 2, int lo0 IPv6 RIP 2 enable, int serial 0 IPv6 RIP 2 enable, int serial 1 IPv6 RIP 2 enable. And so on my top and my middle router, I have RIP with process ID 1. On the bottom router, I have RIP with process ID 2. The process ID is not included in the actual RIP advertisement. So even though RIP process ID 2 sends the advertisement, it's just an advertisement, and the RIP process ID 1 up at the top receives the advertisement and processes it. That's different from EIGRP, where you actually have an autonomous system number, and the autonomous system number is included in the route advertisement. Show IPv6 RIP. Well, let's look at IPv6 route. So I have a RIP route for the loopback of the middle router. So the IPv6 address ends with ::2/128. I have a RIPng route for this. Okay, so I'm on the bottom router. I would expect to see 3 routes. Here's one on the top, the loopback on the top, I'd expect, which ends with a 1. The loopback in the middle, which ends with a 2. And I'd expect to see a /64 route for this subnet over here. And that's subnet 2. And on my router, I see the RIP route for router 2, /128 router 2 loopback. I see the RIP route for the subnet, the /64 subnet 2, and I'm actually seeing it from both RIP neighbors, out serial 0 and serial 1, but that's it. Let me look again just to see if the other one showed up. The other one did not. So why am I not seeing a RIP route for this /128 up here on loopback of top 1? Let's look at the top router and see what there is to see. So top router show int LO0, and it's up. Show run int LO0, and you can see there's no RIP enabled here. Conf t int LO0, IPv6 RIP 1 enable, and now immediately I go to the bottom router, show IPv6 route, and I don't see it. Now I exited out of config mode, and now I do see it. So it looks like it sent a trigger to update immediately after. So when I typed in the configuration command, it didn't, in that case, it didn't send a triggered update immediately. It waited for me to exit out of configuration mode, and then it sent the trigger update. And now my routing protocol domain is complete. Let's look at the RIP database, just for kicks. Show IPv6 RIP, next hops. Never did that command. So here's the possible next hops for the routers that are sending me information that I can use as a next hop, which is interesting. Show IPv6 RIP database. So this is all the information in RIP. It's RIP process ID 2, and I've got a database entry for the top router loopback with my metric and the serial interface and the next hop IPv6 address, and it expires in 171 seconds, which probably means I received the update 9 seconds ago and the expiration is 180 seconds or 3 minutes. That's another reason not to use RIP because in production, because if that loopback if that router up there just stopped sending us updates, it would be 3 minutes before we realize that the route is no longer usable. And having a network where you can't reach a destination for 3 minutes is pretty rough. Imagine using voice over IP in an enterprise, and for 3 minutes nobody can talk on the phone because the IP packets are not getting to the PBX. That makes management upset. Then here is another entry. This is the loopback for the bottom router, and I sent it out serial 1, metric 2, and the next hop IPv6 address and the expiration time. And then now this one's interesting. I'm actually directly attached to this subnet, but I also have the entry in my RIP database. So the RIP database holds all of the route information I received via RIP because the neighbors sent me the information, but I only install it in the routing protocol. But I have my connected routes, which I have to consider putting in the routing protocol. Since I have a connected route for the /126 and I have a RIP route for the /126, well, the connected route has an administrative distance of 0 because directly connected is most believable, and the RIP has an administrative distance of 120, so the directly connected / 126 will work and end up in my route table. Okay, I think that's about it for today. We've introduced RIP next generation to show dynamic routing in IPv6, and the fundamental thing that's different, I mean, it's very similar to RIP in IPv4, except you're not using network statements to activate on interfaces. Instead, you're activating the routing protocol on the interface in interface configuration mode, and that's true in OSPF version 3 as well. So that way you have complete control over which interfaces to enable or disable the routing protocol on. You don't need to worry about a network statement, going into too many interfaces or not enough interfaces. But it can be a bit error prone too, because all you have to do is forget to enable it on one router. Okay, that's it.